Combustion and flame. Introduction. We use petrol and diesel to fuel cars and planes. Coal is used to power electricity plants. LPG is used in our homes to cook food. Now observe the burning of a candle and coal. Candle burns with a flame and coal does not burn with a flame. This is because candle vaporizes on burning, so it produces flame, whereas coal does not vaporize on burning. Let us explore more about the process of burning. Combustion. Let us perform an activity. Take a magnesium ribbon and hold it over a Bunsen flame. Magnesium burns in air with a dazzling white light to give magnesium oxide and heat energy. Now let us perform the same thing with coal. Take a piece of coal with a pair of tongs and hold it over a Bunsen flame. Coal burns in air to produce carbon dioxide, heat, and light. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. And the substances or materials that undergo combustion are called combustible substances or fuels. Fuels that produce combustion are found in all three states of matter, that is, solids, liquids, and gases. Combustion is a chemical reaction between fuel and oxygen that releases light and energy as heat. Now take a look at these substances. Will these substances catch fire? No. These substances won't catch fire when exposed to flame. We call such substances as non-combustible substances. Air is an essential factor necessary for combustion to take place. Let us perform an activity to demonstrate this. Place a lighted candle on a table. Cover the candle with a glass chimney placed on two wooden blocks in such a way that air can enter the chimney. Observe the flame. The candle burns freely as air can enter the chimney from below. Now, remove the blocks and place the chimney on the table. Observe the flame this time. The air does not enter the chimney from below, so the flame flickers and produces smoke. Finally, place a glass plate over the chimney and watch the flame again. The flame this time goes off completely since no air is available. This experiment proves that air is necessary for burning. The sun also produces heat and light energy. But it's not combustion. It is a nuclear fusion reaction. Ignition temperature. We have here a box of matchsticks. Now, will it catch fire on its own at room temperature? No, it won't catch fire. The matchstick starts burning on rubbing it on the side of the matchbox. A piece of paper will burn only when a burning matchstick is brought near it. Now try to burn a piece of wood by bringing a lighted matchstick near it. the wood does not burn. Now sprinkle some kerosene oil on the wood and bring a lighted matchstick near it. The wood starts burning. Kerosene oil and wood do not catch fire on their own at room temperature. A combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. And the lowest temperature at which a substance catches fire is called its ignition temperature. Let us perform an activity to show that it is essential for a material to reach ignition temperature to burn. Take 2 paper cups, one filled with water. Now heat the paper cups separately with a candle flame. What do you observe? The paper cup without water catches fire. But the paper cup with water does not catch fire and the water turns hot. If we continue heating the cup, the water boils in the paper cup. So, why did the paper cup with water did not burn? This is because heat supplied to the paper cup is transferred to water by conduction. Hence, the ignition temperature of the paper is not reached in the presence of water. So, the paper cup does not burn. Petrol, alcohol, liquefied petroleum gas, that is LPG, etc., are inflammable substances. These substances have very low ignition temperature and can easily catch fire with a flame. How do we control fire? Water is commonly used to put out fire. Water reduces the temperature of the substance that has caught fire below its ignition point. This prevents the fire from spreading and the fire is extinguished. Fuel, oxygen of air, and heat are essential components to produce fire. The function of a fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel, or both. Water is the most commonly used fire extinguisher. But water works best for fires resulting from wood and paper. In case of electrical fires, water cannot be used since it can conduct electricity. Water is also not suitable for fires involving petrol and oil. This is because water is heavier than oil, and so water sinks below the oil and oil keeps on burning at the top. Carbon dioxide is the best fire extinguisher for fires resulting from electrical appliances and inflammable materials. Carbon dioxide, being heavier than oxygen, covers the fire like a blanket. Hence, the contact between oxygen and the fuel is cut off and fire is controlled. Carbon dioxide is stored at high pressure as a liquid in cylinders. Dry chemicals like sodium bicarbonate or potassium carbonate also release carbon dioxide near the fire. Types of combustion. Let us see the types of combustion. Combustion can be of 3 types: rapid combustion, spontaneous combustion, explosive combustion. The combustion in which substances burn rapidly to produce heat and light is known as rapid combustion. Bringing a matchstick near a gas stove and burning of magnesium wire in air are examples of spontaneous combustion. Substances like white phosphorus spontaneously catch fire at room temperature. The combustion in which substances suddenly burst into flames without the application of heat is called spontaneous combustion. Combustion reaction that is accompanied with a loud sound is called an explosive combustion. Bursting of firecrackers is an example of explosive combustion producing heat, light, and sound. Summary: combustion is a chemical reaction between fuel and oxygen that releases light and energy as heat. The substances or materials that undergo combustion are called combustible substances or fuels. The substances which don't catch fire when exposed to flame are called as non-combustible substances. Air is essential factor necessary for combustion to take place. A combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. The lowest temperature at which a substance catches fire is called its ignition temperature. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. Fuel, oxygen of air, and heat are essential components to produce fire. The function of a fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel, or both. Water is the most commonly used fire extinguisher, but water works best for fires resulting from wood and paper. Carbon dioxide is the best fire extinguisher for fires resulting from electrical appliances and inflammable materials. Combustion can be of three types: rapid combustion, spontaneous combustion, explosive combustion. The combustion in which substances burn rapidly to produce heat and light is known as rapid combustion. The combustion in which substances suddenly burst into flames without the application of heat is called spontaneous combustion. Combustion reaction that is accompanied with a loud sound is called an explosive combustion.